Okay, let's go ahead and jump right into this. We're looking at Unit 2 of your physics text here. Okay, so we are looking at the forces that operate at distances. Think gravity, think electromagnetic forces. And 2.1 is all about fundamental forces. You can see that there's 2.2 is nuclear forces, 2.3 is electrical forces, 2.4 is gravity, and 2.5 is movement in space. So we're going to, in the future chapters, we'll dig into these a little bit deeper. But right now we're going to do an overview. So 2.1, click on that and let that open. We'll go ahead and get our notes going here. Okay, so go ahead and write your note format that we use, Cornell Notes. Go ahead and write the date that you are watching this video and taking your notes. And let's go ahead and write down an essential question for this, okay? We'll probably go over the engage portion a little bit in class. We're going to jump right into the explore tab. Notice that there's 5 pages, 1 day per page. We're looking at explore number 1. What are the ways in which matter and energy can interact? Go ahead and write that down, okay? What are the ways in which matter and energy can interact? Can interact. Okay. Now, I'm sure you have some thoughts on this. So go ahead and share with me what you already know. Or, perhaps you feel like you don't know a whole lot, but tell me what you think. Okay. Remember, all this is designed to help you turn on your brain, get yourself primed to absorb the information that we're going to talk about. So give this your best. Go ahead and hit pause on the video and write down for just about a minute or so, a sentence, bullet points. What do you know about this? Okay. Okay, Roman numeral 1. As we take a look at our text, and that's what we're doing with our notes here, is we're going to tear apart the text. There's 4 fundamental forces. In physics, you see it highlighted here. I use green to kind of express main ideas. In physics, matter and energy interact through just 4 fundamental forces. Okay, so 4 forces. Okay, and it's worth writing that down. So capital A. In physics, and that's what we're talking about right now, matter and energy interact through just 4 fundamental forces. Okay, and you may have already written 1 or 2 of these items down when you wrote down what you knew. The 4 fundamental forces are the gravitational force, electromagnetic force, strong nuclear forces, and weak nuclear forces. That's it. Okay, so let's go and write those down. Okay, 1, we have gravitational force, the force that causes an apple to fall to the earth from the tree. Gravitational force, electromagnetic force, okay, Okay, maybe you're thinking about electricity. Maybe you're thinking about batteries, positive and negative charges. Maybe you're thinking about static cling when your socks are sticking to your pants when you pull them out of the dryer. Okay, the third one, strong nuclear force, and the fourth one, weak nuclear force. Okay, so we have strong nuclear force, and the fourth one is weak nuclear forces. Okay. And as you look into the second paragraph here, they give an example of friction. They talk about a balloon resting on a ceiling and or even a wall. Why is it that balloons might stick to a wall if you rub them with in your hair? What makes them stick? Okay, so it talks about electromagnetic force being at play there. Make sure you watch the videos. Okay, and again, this is an overview. This is an overview, okay? So the next section in our notes that we're going to quickly discuss just to kind of get us thinking about these general forces is titled Particles, Forces, and Quanta. You kind of know about particles. You've sat through these science classes and you know that there's things like atoms and that they're made up of protons and neutrons and electrons. If that's what you're thinking, you're on the right track. Forces, when you think about forces, you might already think about, protons being positive and electrons being negative, and these forces can be attractive or repulsive. So you're on the right track if you were thinking that. And then you've also been exposed to quanta. You've learned about quantum mechanics when we talked about filling electron orbitals and the different rules as far as electrons having upspin and downspin, that kind of counterclockwise and clockwise spin, that kind of deal, right? And that gets into the quanta. All right, so let's go make this letter B. And we're going to just title that Particles, Forces, and Quanta. And remember, every time you read, and of course, you need to be reading this. Just don't listen to my notes and think that you've read this all, okay? Because I'm really just hitting the greatest hits on these notes, right? You should always check with yourself, what do I already know about this? That way, new things come in, you're reading, and then those are the things you should write, especially if you're not aware of those. All right. So the four fundamental forces explain how different types of matter interact. What are different types of matter? Well, that's solid, liquids, and gases, and plasmas, right? Um, so we'll write this down here. This is going to be number one. The four fundamental forces explain how different types of matter, TYPES, types of matter interact. And when we're talking about the types of matter, we to remind ourselves there's solids, there's liquids, there's gas, and of course, you also know that there's plasma, right? So these fundamental forces explain how these different states of matter can interact, okay? And if we're going to be talking about matter, then it helps to refresh ourselves on what are the fundamental parts of matter. Okay, so matter, it's made up of atoms, right? All matter is made up of atoms, and you know that there are subatomic particles. Okay, we have people that, if you take a look here in the second paragraph, Well, they've got it highlighted here at the 20th century, the turn of the 20th century, subatomic particles were named electrons, protons, and neutrons. And there are many scientists involved in this. Investigations of electromagnetic force by Max Planck and others show that energy and light and other radiation is emitted in packets called quanta. So let's first get to our subatomic particles. We know that you have things like if you have an atom is composed of protons, which are positively charged, neutrons, no charge at all, and electrons, which are negatively charged, right? And in this paragraph, again, this is a survey, right? They talk about how, let's go and write this as letter B. Light demonstrates special properties. It behaves both as in a waveform, what we call electromagnetic, and that gets into the whole idea of packets of energy called quanta. So energy in light. So let's go ahead and light is emitted in packets of energy called quanta. And that's where we get into this idea of quantum physics or quantum mechanics, okay? Protons and neutrons were proven to consist of even smaller particles that were named quarks and neutrinos. So let's go ahead and write this down. So we're getting into, we're talking about quantum mechanics right now. So we could say that protons and neutrons, you know that these are subatomic particles of atoms, but they can be broken down into smaller things. Can be broken down into smaller particles called or named, right? These are things that humans name as we discover them. We call them called quarks. And neutrinos. Okay? And you identify them by their quanta, okay? You identify these by their quanta. Okay? All right. Now, I just want to remind you, this is just a survey. This is just kind of an overview of the things that you're going to be getting in the next couple of chapters, okay? So moving on, make sure you watch the videos. Okay, the videos are designed to shed more light on some of the reading that you're doing. Not all fundamental forces can interact through all the fundamental forces. That's important. Just because there's 4 fundamental forces doesn't mean that all of matter is going to interact using all 4 of them. Some forms of matter may only interact using a couple of these fundamental forces. Okay, so we're going to make a note here. This is going to be, let's go ahead and make this letter number 3, okay? Not all fundamental particles, right? We're talking protons, neutrons, electrons, atoms, neutrinos, quarks, not all fundamental particles interact through all four fundamental forces. Okay. For example, only particles that have an electric charge will experience the electromagnetic force. However, all particles interact through the gravitational force. Okay. I.e., only particles with an electric charge will interact via or through electromagnetic force. Okay, if you don't have a charge, you're probably not going to participate in any type of behavior involving positive and negative charges. If you don't have any of these type of charges, you're not going to be involved with that kind of force. But here's a big but: all particles are subject to gravitational force. All particles interact through gravitational force. Okay. Obviously, the bigger the object, the greater the force, the charge. It'll be affected by gravity more versus if you're a smaller particle, albeit a very, very small force, right? But gravity still is going to affect all these things. Now they go into this next paragraph. Let's see here first. The study of the behavior and relationship of subatomic particles is called quantum mechanics or quantum physics. Okay, let's go ahead and make a note of that. Okay, number 4. The study of the behavior and relationship of subatomic particles. That's your protons, neutrons, electrons, quarks, neutrinos. This is called what? Quantum mechanics or quantum physics. The study of the relationship behavior of subatomic particles is called quantum mechanics. Okay, aka, also known as, aka quantum physics. Right? We can thank Einstein for that, right? And this is juxtaposed or compared to, say, Newtonian physics. Newtonian physics really didn't address this subatomic world, okay? So, moving on to the next paragraph, then. The standard model of particle physics is a theory that describes the interaction of 3 of the 4 fundamental forces: electromagnetism, strong nuclear force, and weak nuclear force. Okay, so that's called the standard model of particle physics. It's funny they don't have that bold print at all, but let's go ahead and make a star here. Okay, you have the standard model of particle physics describes the interactions of only 3 of three of the four fundamental forces. Fundamental forces. So the standard model of particle physics is going to look at the electromagnetism, strong and weak nuclear forces. Okay, that's the standard model of particle physics. Versus gravity is described by the theory of general relativity. Versus gravity, which is described by the theory of general relativity. All right, good. All right, so moving on, okay? Where are we at here? We're on, we've done 1, 2, 3, and 4. We've been talking about particle forces and quanta. We've been talking about 4 forces. Let's make this Roman numeral 2, okay? Roman numeral 2. Quite a bit of information, I guess, for an overview. Okay, Roman numeral 2. And again, this is just a survey. Now let's talk about dark matter and dark energy. This is what actually makes up most of our universe. What the heck is it, right? Dark matter and dark energy. Certainly sounds like something out of a science fiction movie, right? So in green, the main idea here, most of what we know about matter is revealed to us in the ways that mass interacts with light and behaves under the influence of the fundamental forces. Most of the mass in the universe, about 83% of it, seems to be perceptible only by its gravitational influence. That's interesting. This form of matter is called dark matter because it does not emit, absorb, or reflect electromagnetic radiation. So we can't really study it using those other tools that are related to electromagnetism or strong or weak nuclear forces. I know I'm saying a lot here, and you may have to replay this video just to listen to some of the things I'm saying there. Okay. But we're just going to say most of the mass in the universe, make that capital A, what are we talking about? 83% seems to be perceptible only by its gravitational influence. Okay, we can't perceive it through the other 4 fundamental forces, the other 3, electromagnetism, strong or weak nuclear forces. We can't perceive 83% of the mass through those other forces. And this is called dark matter. Most of the mass in the universe seems to be perceptible only by its gravitational influence. We call this dark matter. dark matter. Okay, it's not perceived via the other types of forces. Okay, now if you thought that was kind of hard to wrap your head around, let's take a look at this next paragraph here. Similarly, the energy of the universe. So we just talked about matter. Now let's talk about energy. Similarly, the energy of the universe has a counterpart known as dark energy, which was postulated by scientists who were attempting to determine the influence of gravity on the rate of expansion of the universe. Okay, so let's make this letter B. The energy in the universe has a counterpart, kind of like an evil twin, has a counterpart known as dark energy. Okay. Okay. Now, they're not going to go into great detail here, but they're going to talk about the expansion of the universe, the idea that the universe is expanding at a faster and faster rate, even though theories would suggest that the universe should be slowing down as the universe gets bigger. And so that's where this dark energy kind of starts to come in as a theory. Okay, and we'll talk about this a little bit more. And of course, what I want you to do is I want you to watch the video, okay, and kind of just get yourself introduced to these ideas, okay, of dark matter and dark energy, along with the other things that we talked about here. Okay, all right. How do I want to finish this? Let's read this bottom part here. Dark energy. We cannot see, touch, or detect dark energy, but scientists know it is there. What evidence do we have that suggests the existence of this dark energy? I want you to watch that video, okay? And we'll talk about this in class, okay? All right, so that's going to finish up our notes for right now for the Explore one. You know what I want you to do. I need you now to write me a summary sentence, actually a summary paragraph, okay? A summary paragraph. Okay, so make this, 2 to 3 sentences in your own words. This is the key. In your own words, try to think about what we just took notes on, what you just heard me say, and in your own words, re-say it. Okay, try not to look at your notes. Just try to do it from your own recall. All right, that's it. We'll talk to you guys soon, all right? Bye-bye.